Welcome to this talk where William will teach us how to become an ISP.
So welcome. This is a case study into the series of troops writing with cat videos, which is also known as the internet. So who am I and why are you listening to me? I am the former chairman and I've been in operations for 4 years at Konet.dk, which is a student-run ISP over in Copenhagen in Lyngby that provides the internet for all the DTU dorms and one of the oldest ISPs in Denmark. And I'm also was the Supreme Packet Lord and Switch Commander at the Nyborg dorm. I also gave myself that title because there was no one to tell me I couldn't have that title. And then I also got my my bachelor's in Networks Technologies and IT from DTU, which is now called Cyber Technology. So what is an internet service provider? They do other things that just annoy you with their terrible customer support. They actually provide a useful service, which is the internet. So quick step, let's create our own. So what you do, you go on your phone, you turn on a personal hotspot, you have someone pay you 5 kroners for the network, and that's it, you're done, that's your ISP. Obviously there's a bit more to that, but that is basic how simple ISPs work. They just share a connection they get from someone else. So ISPs, they come in 3 different tiers. There are tier 1 ISPs, these are big guys, some of them you've heard of, some of them you haven't heard of. Then there's tier 2 ISPs, with things like TDC, Global Connect, formerly Neonet, Hurricane Electric, whole bunch of companies. And then there is tier 3 ISPs, which is, Fiberby, full rate, Bornhack's internet connection, that's a tier 3 ISP as well. And let's start with tier 3s at least, because these are the simplest ISPs. They're like humans, come many different shapes and sizes. What they do is they pay entirely for their internet connection from a tier 1 or tier 2 ISP. And what they do is provide the last mile coverage. And as I said, they can come in very different shapes and sizes, put it this way, in scale. So it could be an antenna pointing in your apartment building, which just has a patch panel down in the basement, and then make sure to put together a deal with some tier 2 ISP to get internet to the entire building. Or it can be a bit more complex than that. So we are going to take the case where we are Bornhacknet, the newest ISP on the block, and through some sort of sitcom situation, we have ended up having to provide the internet connection for the new Lynetteholm Island in Copenhagen, which is being built. So the requirements, we need to provide internet for at least 1 apartment building. We want to scale it up, to more, 49 plus is what we're going to say. We also want to comply with the Danish logging regulations, because sadly, we have to do that, and we want to prioritize getting this set up as fast as possible. So we're going to have very simple topology here, where what we're going to do is we are going to find some tier 2 ISP. We're probably going to go to Global Connect and say, hey, we're starting an internet provider. We want some internet. And they'll say, great, here's a fiber panel you can connect to. We'll give you 1 gig of internet, 1 gig per second of an internet connection, and we'll give you who knows how many IP addresses you ask for. And obviously, we're not going to give us that many IP addresses, so we're going to want to route this into a router with NAT support. This is network address translation. So this is where you take there's the Bornhack NAT network. I'm pretty sure you all know what NAT is, at least. And then we're also going to want a DHCP server to provide, IP addresses to all the people living in apartment buildings. And then we're going to want to run cables from our main router, which takes the fiber connection in from the tier 2, and we want to send that into switches in different apartment buildings so we can send connections to different apartments. All done? Obviously not. There's issues here. So we don't have isolation between the individual apartments. Everyone here is in the same broadcast domain, which means all devices could see all other devices. This also doesn't live up to the logging requirements, and it's really not scalable because we're not going to get a core switch which has more than 48 ports. So here, what we want to add, and yes, this diagram has issues in it. It's the exact same as the one from before. What we want to add here is, first of all, we want to add a firewall in between our tier 2 ISP and our router. Generally, we want to get like an ISP grade 1 because this will allow us to get all the logging we need to comply with the Danish requirements. And here, the Danish requirements, they are that we need to log the metadata from connections. So we don't need to we don't need to log the actual data as being transmitted, but we need to say this IP address accessed this address, this other IP address at this time, and it was this person that was behind it. This is what happens if the forwardies come. Then what we also want to do is we want to fix this issue with the broadcast domain. So this can be done for lots of different ways. But the easiest way is to use what are called VLANs, virtual LANs, where we'll then assign each apartment with its own VLAN, its own virtual LAN. And this way there will be isolation between each apartment. And of course, also, we want to make this scalable. So this would include then, we could add more routers in between here. So we have our core router, which will connect to a second layer of routers, which will then connect to the switches in the apartment buildings. And then you could have a router for every 10 buildings or whatever. Next, great, we have a very simple ISP, and honestly, this is not more complex than what some people even are running at home. Tier 3 ISPs are simple. But Tier 2 ISPs, this is where we get the more interesting stuff. This is where we learn a bit more how the internet is actually structured together. They also come in many different shapes and sizes. What they do is they can pay for transit from others. This is what we were doing before with the other Tier 2 ISP, where we were paying them for the connection. However, they can also engage in peering with other networks. And peering is the networking version of sharing is caring. So peering, when two networks love each other very, very much, they celebrate by peering. And this occurs, peering involves networks connecting to each other and say, okay, let's freely exchange data with each other. You have a data center on your network hosting on Facebook, let's say, and I want to access Facebook for free, so let's set up a peering agreement. And most of the time, if we ignore Cognant, because they aren't so nice, most of the time these peering agreements are free, and a lot of time they're also informal as well to a certain degree. It's not big legal contracts I need to get through as well. And peering occurs at internet exchange points. These internet exchange points are this is the core infrastructure of the internet. So if peering is consensual interchange of packets, then IXPs, internet exchange points, are the internet swinger clubs. It's where ISPs meet, they connect to the ISPs connect to the IXP, and then they'll get a connection in the switch here, and then they can go into peering agreements with other ISPs. So peering, as I said before, free, sort of informal process. Generally, what a Tier 2 or Tier 1 ISP will have, they will have a peering policy that they can say, okay, if you follow these rules here, then you can peer with us. So Hurricane Electric, for example, which is one of the largest Tier 2 ISPs, they'll say, okay, you only send traffic which we are announcing to us. You have to peer with us at all ISPs that you are present in, and so on. And peering policy, as I said, both parties need to follow them. And to peer, we also need what's called an AS, autonomous system. So what in the world is an AS? It is fancy nerd speak for just having a set of IP addresses. So here at Bornhack, we even have our own AS number, I believe. We do. And what this AS is just a way to say, okay, all these different subnets that we have from the IPv4 and IPv6 ranges, they belong to these organizations. Autonomous systems are assigned by the regional internet registries. So in Europe, it's the RIPE NTC. There is ARIN in the US, and then there's a couple others which I can't remember. And generally, they aren't free, but they aren't that expensive either to get. And the only requirement to have an AS is really, at least out in the public-facing internet, is that you need to have some IP addresses, which IPv6 addresses you can get freely pretty easily once you are registered at a regional internet registry. And IPv4 addresses, well, they're kind of expensive nowadays because we've run out of them. So how do you peer to? So first you get a lot of money because you are going to be digging a lot of fiber cables to your nearest IXP. You can probably pay to use another internet provider's fiber cables as well, but eventually you are going to need to be able to hook up to the IXP. And as said, they're in certain locations. So here in Copenhagen, for example, here in Denmark, for example, the oldest IXP is in DTU building 304. So if you were to start an ISP out there where we said in Copenhagen of the new Lynetteholm Island we're building, you need to have a fiber connection from your offices there or from your data center there all the way to the IXP. And then obviously we add step 3 and then we get profit, right? not that simple, obviously. Things never that simple. So for peering, there's a bit more technical. Obviously, once we have reached out to a couple of tier 2 ISPs and they said, yeah, let's peer, that'd be great, we can freely exchange data. You need to set up some routing protocols as well. And the main ones that are used is OSPF, Open Shortest Path First, which is also what's on my t-shirt, this is an IGP, or an interior gateway protocol, where this routes within your AS. Because obviously when we're getting this point here, we've scaled a bit up from the simple having one core router and a couple switches and a couple apartment buildings. Here we would generally be having several main locations we are accessing from, and we're going to be routing around in this as well. So we use the OSPF protocol. And this can recover from failed links. It could also do traffic engineering. And from the name, Open Shortest Path First, it takes the shortest path that's available first. Next, once we want to route traffic to another AS, we use what's called BGP, the Border Gateway Protocol. And this is the main protocol behind the internet, and by default it is hilariously insecure. And like, seriously, if you actually set yourself and go really dig into BGP, you're wondering how the hell does the internet work? It shouldn't work. So here we're going to have a little side rant, which is why BGP is a terrible protocol. Brief history, originally on 2 napkins, back in 84, but I'm not fully sure about the year. On 2 napkins, they defined the Border Gateway Protocol. So, simple protocol at least. There are some issues with it, however, and I'm not going to go into explaining how the protocol works in general. This can be reading for yourself afterwards, because it can get a bit complex at times as well. But some issues with it are there are bad distance metrics. So how BGP chooses hops, next hops, for OSPF, it would choose the shortest path. Here, the issue with BGP is it uses AS path. So how many autonomous systems would a packet pass through to get the shortest path? The issue is some of these autonomous systems can have huge geographical distances. So if you were to send a packet, if you're in Singapore and were to send a packet to a server in China, it could get routed through Los Angeles, which would, you're going halfway across the world there and back again for something which should not be that distance as well. Another issue with it is manual manipulation of this next best hop is also possible. And because of this, not as friendly ISP would try to discard peering traffic, and this means it would be then sending it on to another AS, because they want the transit traffic. This is the traffic that's generating them money. Transit traffic could also then be maliciously routed for financial gain. So they could say, oh yes, it's maybe 1 hop, but our contract says you pay us for every single hop that we do, so we're going to route it through 5 hops to earn some more money. BGP, by default, also trusts a bit too much, as ASs can advertise routes they do not own. This is Bgp Leaks. For example, back in 2019 a large part of the internet was knocked down. This was because Verizon and another small American ISP, which were buying their transit from Verizon, the small ISP, they were using a BGP optimizer, piece of software to help them optimize their BGP routes. And what happened is they accidentally advertised a whole bunch of routes which they didn't have access to. So they said, hey, you can reach Google, you can reach Cloudflare, all these IP addresses, you can reach them at us. And then they sent it onwards, and BGP is a gossipy protocol, so they sent it to Verizon, their internet service provider. Verizon should have said, hey, you obviously don't own all these IP addresses here, other people do. I'm just not going to send it forward. But they didn't, because either they had configured something wrong, or they didn't go too much into the post-mortem, of course, try to save a bit of face. And what happened is large parts of the internet went down, because suddenly Cloudflare, Linode, and a whole bunch of others were routing to this one ISP in Pennsylvania. Not the best. BGP leaks can also be maliciously made. So it has occurred several times before, where countries such as China and Russia, they will leak BGP routes, which is saying they'll set falsely advertised routes, and when traffic will then, maybe quickly it happens, sometimes it's for a long period of time, where they'll route traffic through their own AS. Maybe this is just used for data collection, or who knows what it's used for. And yeah, this is also just what is taught by Bgp Leaks. So we know a bit about BGP. We know how it works. We know how to peer as well. We go make an agreement. We set up our configure our BGP protocol on our core router to say, yes, we want to peer with these ASs here. All good. So what else can you do as a tier 2 ISP? And this is where there's some fun stuff going on. You can get free hardware if you ask Google or CDNs or Netflix or whatever, because they obviously want to get their static content, they want it to get as close to the internet, to the users as possible, because this then they avoid a whole bunch of transit traffic they have to pay for in that, and also lower latency. So you can go to Google and say, hey, I want to peer with you, and I want to get a cache box here, and they'll go, great, they'll check if you fulfilled the requirements, and they do, they will send you a box that you slot into your data center, and then they'll cache static content, which becomes popular. This could be things like YouTube videos or ads for YouTube videos, which is why ads always seem to load faster than some obscure video you're trying to watch at 3 in the morning. You can also register really dumb IPv6 subnets. For example, dead beef. That's a valid IPv6 address. It's not assigned to anyone. There's a whole bunch of hexspeak IPv6 address subnets that aren't assigned to anyone. You can also cry a lot, because maintaining a tier 2 ISP is a lot of work as well. It's not too easy. And you can also make lots of money, because that's what we're all here for, learning to make money in a business. So how do you become tier 1 ISP? Lol, you don't. Tier 1 ISPs is literally a cartel of ISPs who say, okay, we'll peer with you guys, and we won't peer with anyone else. And if someone buys transit off them, then the people it peer with also get access to that route there. So really, you really want to know how to become tier 1 ISP. So this part here, this is, I didn't have time to make these slides. But here's theoretically how you could become a tier 1 ISP is, first of all, you would not need to peer with any other network to begin with. Yet you would somehow also need to have an internet service which was so hugely popular that through transit, you would end up costing these tier 1 ISPs lots of money. So say if you were Google and you somehow created, they created a global spanning ISP and they got a lot of customers and they said, okay, you have to pay us now for transit. They say to all the tier 1 ISPs, you have to pay us for transit. They're not going to be too happy, and maybe, just maybe, they would let you into this cartel of tier 1 ISPs. But really, that would also mean, you're taking yourself off the internet to get access to the internet. It's not really possible to become a tier 1 ISP. And generally, this cartel also becomes smaller and smaller because Layer 3 keeps up buying more of the other... Lumen Technologies bought Layer 3, where Layer 3 bought someone else, and they're basically all just becoming one big monopolistic ISP. But however, you can avoid tier 1 ISPs to a certain degree, as there are some really big tier 2 ISPs who will peer with lots of people, and they can peer with basically every other tier 2 ISP. Again, thank you for the talk. I know this might have been a bit short. I actually have no idea how long it took. You can contact me on email, on LinkedIn. I realize that's also my email, or you can just find me in a pajamas camp with the other people in pajamas, or you can find me at the bar if you want to have a chat.
Yes, we got 25 minutes for questions.
Longer than I expected.
If you rather not answer this question, say that you didn't understand me, how does the Bornhack Tier 3 ISP comply with the logging requirements of Denmark?
I would direct your questions to the network team sitting right there, those fancy gentlemen. I think the answer could very well be they're not. I know there are some ISPs. The one I was chairman of, we didn't follow the Danish regulation. We followed the EU regulation because we didn't fully agree with the Danish one.
It's a long story, but in short, if there's an upstream network logging already, you don't have to log. And it has been the policy of logging in the Bornhack network since I've been here from the start, 2016, when we did the first one. We are logging as little as possible. We are only looking at traffic if we need to debug stuff. So in general, we are not logging. We are logging a little bit because we are monitoring the network using LibreNMS, and then we are like deleting those as fast as possible when we get home. As little as possible.
I can also just add that there's also not any logging happening of the Bornhack connection at the upstream. And we have a little bit of S-flow in between that gets aggregated, but that is only transient and not stored. And then in addition, if anyone has an AS number and some address space and wants to announce it here, we can probably figure that out. Come talk to the NOC.
Any more questions? 20 minutes left.
Otherwise, we can go to the bar and have questions and beer.
Thank you very much for the talk.